So let's start our today's session.
Mm-hmm.
In today's session, we'll be starting a new unit. This is the second unit of that AP curriculum. Electric charges and field. So this is the unit which we can say has the most number of practical applications around us, and we generally sees it around us most of the time. So in this chapter, we're going to find out some interesting real life applications like why these tankers have chain hanging from them, why these particles are rising, what is the
Mm-hmm.
basic cause behind them. You must have done it, right?
Somewhat, yeah.
So these will be the topics we're going to discuss in today's class.
Mm-hmm.
We're talking about what is electric charge exactly. How can we make a body charged one? What is electroscope to be precise, and the force which governs these principles. So again, electrostatics. This is the name of the unit to be precise, in which this electric charge and field chapter comes. So electro means charge, static means at rest. So it is basically study of charges at rest to be precise.
Mm-hmm.
That how charge behaves when they are not moving, they are static, and what damage they can actually cause if they move.
Mm-hmm.
So we'll be studying about electric field, that electric field which originates due to this static charge. Like for example, if we have a positive charge, let's say, so it will be emitting its field, which is electric field. So
Mm-hmm.
that magnitude of this field, or you can say the strength of this field, depends upon that what that how much of charge is being placed here. Like what is the magnitude of that charge? The strength completely depends upon its magnitude, that how big it is or how large it is in
Mm-hmm.
terms of numbers. So these are called electric field lines. We'll be talking about electric field lines as well. The most important thing we are understanding here is induced charge. Now, like how can we actually induce some sort of charge in some metallic body? Again, it needs to be metallic body, then only it can take charge.
Mm-hmm.
So how can we induce charge in it? What are the methods of inducing charge? What is induction to be precise? What process it is? So in order to understand all these concepts, we need to first understand what is charge, what exactly charge is. The significance of electrostatics is something which we look around ourselves in a lot of sense. The first is you can say batteries, or you can say cells. Because of electrostatics only, we are able to understand what is electric cell, what are batteries, how can we charge, discharge them. Again, that word charge.
Mm-hmm.
So everything is associated with electrostatics only. So you can say whatever appliance you are looking at, we are around is something because of electrostatics. Because we somehow understand that how charge flows, what are the characters of charge, what magnitude of current can be flown because of this charge available in the battery. So we can calculate each and everything. And on that basis, we have different range of batteries as per their use. So understanding law of charge. There is another word called charge density. We'll be looking
Mm-hmm.
at it also later in the chapter. So there are various charge densities for different type of objects we have around us. All right, let's move ahead. Static
Okay.
electricity. Okay, one thing we can do, like I can give you some questions as a part of your homework. So you can
Yeah.
try those questions out. Like
Yeah.
in this PDF only, I'll get some extra questions, which I'll mark it as that these are your homework. So when I
Mm-hmm.
send you the notes, you'll ultimately get the questions also, which was supposed to be your homework.
Okay.
So after every class, we can discuss that. That is, did you have any doubt on those questions? Like there will be some numerical part also,
Mm-hmm.
like a lot. Like suppose you're getting 10 questions as a part of your homework. So during one day doing that 10 numericals, so it was not supposed to be easy at all, first of all. It might
Mm-hmm.
take sometimes longer time, sometimes might be done in like 10 or 15 minutes. Something
Mm-hmm.
like that type of questions are also there. So what you can do is I'll just try to give the balance thing. And there was no pressure of doing that. You have to do that question by next class only. It isn't like that always. You
Mm-hmm.
can do it at your own pace as it is a summer camp. You don't need to take this education or this classes as a burden. So as per your interest only, that if you feels like that you are interested enough to do those questions, you should try them. And if you
Mm-hmm.
have any doubt in those questions, you can ask me before the class, next class.
Yeah. Mm-hmm.
All right then, let's start it. So static electricity. So in order to understand static electricity or something, we have to understand what is electric charge. So this is where the chapter begins. First topic of our unit. Basic property of matter carried by some elementary particles that govern how the particles are affected by an electric or magnetic field. Now, it is a very complex definition of what is electric charge. In simple words, if I make you understand, so electric charge is something which is an intrinsic property of any matter, any type of matter. Like electric charge is something from which matter must have been made, or you can say matter always contains electric charge. So it is an intrinsic property. It is there in every metal, every matter, not metal. So electric charge is something like that. And this type of matter, like this type of particle present in the matter, they are basically uh, carried out by some form which is sometimes termed as electrons and protons, positive and negative charge to be precise. And these particles are something which is affected by electric and magnetic field. So this is how it is defined. What is electric charge? Technically to be precise, more precisely. So just remember the word, it is an intrinsic property of matter. Like without it, it should not be present. We can say that. So there are two types of electric charge. One is positive, which is given by protons. One is negative, which is given by electrons. So you must have known that atom contains nucleus plus electrons, and protons are there in the nucleus only. The charge of electron or proton, whatever it is, electron is represented by E minus and proton is represented by E plus.
Mm-hmm.
The charge of proton and electron is same depending upon the sign. If it is electron, it would be negative 1.6 into 10 to the power minus 19 Coulomb, or if it is electron, it is minus 1.6 into 10 to the power minus 19 electron. So
Mhm.
it depends on which type of matter, which type of charge we're talking about. So remember this value of charge, it's very important. Or I guess you must have seen it before as well. Have you?
Mm, no, I haven't seen that.
All right. So let us understand what are the charge carriers in different type of matter which we see around us. So conductors. So conductors has charge carriers as free electrons. The conductors have free electrons. Like these electrons are literally free and they can move out if they get sufficient energy. By although all the rest of the electrons are not free, they are bounded to the nucleus. So they cannot like escape from the conductor. Like
Mhm.
electrochemical cells has ions present in them as a charge carrier. They actually does that work of charge carrier. Like if we talk about photons, so photons has holes and electrons as charge carriers.
Mhm.
In nuclear reaction, we have several particles, neutrino, antineutrino, like something like that. We'll be learning in the last unit of this entire course. What are these charge carriers are? So, a very simple and common example, a question. Charge carriers in a metal are electrons rather than protons. This is due to the fact that electrons are. So, this question is supposed to asking us some properties of electron, or
Mhm.
you can say some properties of charge carrying electrons. So, charge carriers, whatever charge carrier is present in metal, they are electrons rather than protons. So, protons are less in number, electrons are more in number. This is what it's supposed to say. Electrons are more in number. This is due to the fact that electrons are loosely bound, lighter, far from nucleus. So let us understand each example, each option also. Because whenever we are attempting an MCQ, the most important thing is you should know that why other options, which are not the answer, why
Mhm.
they are not. Then only you can answer. Then you can be very sure about what is the exact answer. So we need to be very sure. First thing is electrons are loosely bound. So somewhat yes, electrons are loosely bound in comparison to the protons. So they can easily escape. Like if we
Yeah.
look at the atom has a
Mhm.
nucleus and the nucleus only protons are there, whereas electrons are there in the orbits of that atom. So if it
Mhm.
is in the orbits of that atom, so they are sufficiently far from that proton thing, so they can easily escape.
Mhm.
So somewhat this option is correct. That yes, electrons are loosely bound. Next, if you look at the thing, this is lighter. Lighter means the in comparison when we are comparing their masses. So proton is supposed to be a heavier mass and electron is supposed to be a lesser mass. So let us have a look at it. Look at this masses. So electron has a mass of 9.1 into 10 to the power minus 31 kg.
Mhm.
Whereas if we talk about the mass of proton, it is only 1.67 into 10 to the power minus 27.
Wait,
So here we
isn't it
can
then
simply
what is
see,
the 1.6 times 10 to the power negative 19?
no, it is a charge of electron. That number which we are talking about,
Oh,
that was a
okay.
charge of electron, 1.6 times 10 to the power minus 19 Coulomb. This is mass.
Okay,
The
got
option
it.
B says that electrons are lighter in mass. So yes, electrons are lighter in mass. You can check their masses. Proton is much heavier than that of electron. So they can easily escape. So this option is also ideally correct.
Mhm.
Next is far from nucleus. So yes, electrons are far from nucleus. So this option is also correct. So the correct option would be D, that all of the above are correct.
Mhm.
So this questions basically teaches us that the properties of electron. Electrons are loosely bound, lighter, and far from the nucleus.
Mhm.
Charge on alpha particle. So again, this is another type of charge. Alpha particle is
Oh,
something called
Algebra.
Do you know what is alpha particle?
No. I thought for a second it was talking about the electron, then I confidently said it was B, but then I didn't read the question.
Hmm. So alpha particle is basically doubly charged helium ion. So helium ion is, if you know its atomic number, what is the atomic number of helium?
Mm, I don't remember.
You have taken chemistry in the last semester. This is what you said.
I took chemistry 2 years ago. um,
All right.
yeah, I don't remember what atomic number it is.
It, it's two. Hydrogen, helium. It comes second under the periodic table.
Oh,
So it
mm,
has, if its atomic number is two, so it is supposed to contain two protons.
mm-hmm,
This is what its atomic structure says. Helium. So two protons means twice of 1.6 into 10 to the power minus 19. Charge of one proton is 1.6 into 10 to the power minus 19. We have
mm-hmm,
to multiply it by 2. And whatever answer we got, we again have to multiply it by 2 because it is doubly charged helium ion. So alpha particle is something which is twice of charge of helium ion's charge. So
mm-hmm,
helium's ion charge is this, and twice of it is the charge of alpha particle.
mm-hmm,
So when we calculate it, we'll simply get 6.4 into 10 to the power minus 19 coulombs. So this is
mm-hmm.
what charge of alpha particle is. So basically, we were supposed to calculate, first of all, the charge of quantities around us. And these quantities are nothing but which contains different type of charges. So alpha particle is something which is used by Rutherford in his alpha particle scattering experiment. This experiment was conducted to give the structure of atom. So that's why this particle has become more important in physics as well as in chemistry. That's it. So its charge is something which is commonly being used in questions to refer something. Like what is the charge of that given object A? So someone says it's four times that of alpha particle. So alpha particle charge is something which might be used to represent someone's charge. That's why we need to remember it or learn it.
So I have a question.
Yes.
So on the last slide, like it's saying what's the charge of an alpha particle, but like why are you doing it for helium specifically?
This was something which is done by like the
Is that
organization.
is that the only
No,
alpha particle?
no. There are many particles which contains different type of charges. So that charges is something which is being used to refer it. So alpha particle is somewhat very close to helium, you can say, because it is, if you look at the structure of helium, its structure says that there are two heliums and they are somewhat connected by this bond, which is called coordinate bond.
Mm-hmm.
So the structure says it is doubly charged helium ion. So that is what alpha particle is.
Oh,
So something which we have seen and then we have given it that is the charge of it.
okay.
Next, can charge be transferred without the transfer of mass? So as we have seen in the last slide, that mass of electron is 9.1 into 10 to the power minus 31 kg, and mass of proton is 1.67 into 10 to the power minus 26 kg. So if charged particles are actually possessing mass, so when they are getting transferred from one object to another, so it must be like mass is transferring because if electron is going, then it is carrying its mass, na? So if its charge is transferring, so electron So the mass of electron must also be transferring. Similarly, if proton is transferring, so the mass of proton is also transferring. So its answer should be like this is again a property of charge. Like whenever charge transferred, so it actually transferred of mass. So what is the mass of that amount of charge which is being transferred? We can calculate that charge by simply using a property of charges. So in order to understand this properly, let us move to the properties of charges. There is a property of charge which is called quantized. Quantized means something which is multiple of one number. That is something which means quantized. So charge is quantized, so we can calculate the total charge of any object by multiplying a number into charge of electron. Like suppose if we have 10 gram of something, we can actually calculate its charge
Mm.
by using some sort of chemistry and some sort of physics. We can calculate the number of electrons that object of 10 grams must be possessing. We have that chemistry and we have that physics to calculate the total charge it might possess. So that is the property which says that it is quantized. We can calculate it. You just need a number only. If you somewhat get this number, like in terms of anything, you can ultimately get the total charge.
Mm-hmm.
So we will say yes, charge. If charge transfers, mass is also transferred. So it cannot be transferred without the transfer of mass.
Mm-hmm.
Next question. Okay, just 2 minutes. I'll be back.
Mm-hmm.
Did you tried it?
I don't get how to do it.
All right, let me try to explain it. One metallic sphere A is given a positive charge, whereas another identical metallic sphere B is given of exactly same mass as of A is given equal amount of negative charge. Then, so basically we have to explain here that what is heavier,
Mm-hmm.
or like how a charge is supposed to get transferred so that we can actually change the mass change, to be precise. We can
Mm-hmm.
actually see the change in terms of mass when we have given this amount of charge to two spheres.
Although it's saying they have the same mass.
Yeah. So sphere A and mass of sphere B, they both are same. It is given positive charge of same amount. It is given
Mm-hmm.
negative charge of same amount. We have to calculate their total masses. Let us try to do this. So total positive charge is supposed to be Q times that number of times. So let us see the mass of electron and mass of proton once again. It is 9.1 10 to the power minus 31. It is 1.67 into 10 to the power minus 26. 27. So mass of proton is way more heavier than mass of electron. So if sphere B gets electrons, what does it mean? That it has get lesser mass. So mass of sphere B will be less than mass of sphere A. Initially the masses are equal, but finally this happens. So what we can say about this condition? That mass of sphere B is greater. So if we read the options, mass of A, mass of B still remains equal. This is highly wrong. They both changed. Mass of A increases. Yes, this is correct statement. Mass of A increases. Let us see the wrong options also. Mass of B decreases. Mass of B decreases. This is also correct. This is also going to happen. Mass of B increases. This is also wrong. So there are two correct options and two right options, two wrong options in this question. Did you get it? Like what we exactly did?
Mm-hmm.
All right, let's do another problem. Now, this is something which is like very fundamental. You not only need to understand it, that what it is, you actually need to know that how it is calculated. So
Mm-hmm.
the question says how many electrons are required to make charge of 1 coulomb. So in order to understand charge, we need to understand the unit of charge. So charge is basically something which is represented by coulombs. Again, coulombs is given after the name of the scientist who discovered charge for the very first time.
Mm-hmm.
We actually have to find that how many electrons are exactly required to make 1 coulomb of charge. The total charge is 1 coulomb. It's something which is equals to number of electrons into charge of electrons. Like in order to understand that how many electrons are required, so what we were supposed to do, we would simply multiply the number of electrons into charge of electron. When
Mm-hmm.
we calculate that number of electron which is actually required to be found, that is something which is equals to Q by E. Q is 1 coulomb and charge of electron is 1.6 into 10 to the power minus 19 coulomb. So number of electron is coming out as 1 by 1.6 into 10 to the power 19. This goes in the numerator and becomes positive. You
Mm-hmm.
must know this step, right?
I don't understand.
You don't understand? I guess you must know this step. This 10 to the power minus 19 is in the denominator section. So when
Mm-hmm.
it goes up in the numerator, what is the basic properties of exponent? That when
Oh yeah,
it
yeah. The
comes
negative.
to
Oh yeah, okay, yeah, I get
becomes
this.
positive.
Yeah.
N can be written as it becomes this 5 by 8. If you solve it, we'll get 6.25 into 10 to the power 19. So this much number of electrons are actually required to get that 1 coulomb of charge.
Mm-hmm.
So coulomb is not a small unit. It is a very big unit because
Mm-hmm.
that much number of electrons will make 1 coulomb. So that's not a small thing. It's a huge number. So again, this is fundamental and you should know this number 6.25 10 to the power minus 19 electrons.
Mm-hmm.
One more. How many electrons are required to create a mass of 1 gram? See, this is very technical thing. So physics is something which is cu uh, which requires being curious. Like you're seeing things around yourself. So you just have to act, not act like this that you know that how to calculate the charge. You should actually see the charge present in it. You should
Mm-hmm.
be able to see the charge present in it. That should make you be more declined towards the subject. And this thing will make it very being very curious to understand what more fundamental concepts we are
Mm-hmm.
hidden with. So 1 gram means we need to understand the mass of one electron is 9.1 into 10 to the power minus 31 kgs. So 1 kg of electron would require 1 by 9.1 into 10 to the power minus 31 electrons. So if we solve it, we'll get electrons, but we don't need to solve it. We have to first make it grams. So 1 gram would require what we did in order to find 1 gram. We simply divide the whole equation by 1000. This one. So here you're supposed to get 1 grams and it becomes 10 to the power minus 28.
Mm-hmm.
So 1 by 9.1 into 10 to the power
Where did you get
28.
this from?
Which number?
28.
It is 31. It is 10 to the power minus 31. It is 10 to
Mm-hmm.
the power 3. If we solve
Oh,
the
okay.
exponent, then
Yeah.
31 plus 3. So
Mm-hmm.
minus 28.
Yeah.
And this minus 28, when solved further and bring to the numerator, it becomes plus 28.
Mm-hmm.
1 gram would be 1.91 times 10 to the power 28.
20.
Now let's solve it further. 10 by 91. You can actually divide it as you can use calculator in the exams.
Mm-hmm. 0.10.
10 divided by
0.109. Oh, this is no.
0.109 into 10 to the power 28.
Yeah.
This much number of electrons is required to create 1 gram of mass. So
Mm-hmm.
again, that's a huge number.
Mm-hmm.
Let's move ahead. Another question. If one 1,010 electrons are required by the body every second. The time required for the body to get a total charge of 1 coulomb. So now this is becomes. So if you can imagine the each question, they are like different situations. We are supposed to
Yeah.
calculate the charge or
Mm-hmm.
supposed to use the charge. So in order to actually understand or actually solve them, you need to actually visualize them that how things are being going. Like suppose there is some source which is continuously transferring this much electrons to a body A, like every second, that much number of electrons are being dumped into it.
Mm-hmm.
So we calculate that how much charge is actually being transferred in with this time. Then we'll calculate the total time in calculating 1 coulombs of charge. So 1 electron's charge is 1.6 times 10 to the power minus 19, and charge of 1010 electrons would be 1.6 into 10, 1010 into 10 to the power minus 19. So that charge is supposed to come as, just calculate it using calculator and let me know.
Uh, 1,616 times 10 to the power negative 19.
We can solve it further
Mm.
and you'll get around 1.616 times minus 16. This is the charge which is being transferred every second. We have to calculate that how much time is it required to transfer 1 coulomb of charge.
Mm-hmm.
So what we do? Again, we do the same elementary method. 1 second, this much charge is transferring. X time, X seconds will transfer 1 coulomb of charge. We'll simply divide this equation and we'll get X is nothing but 1 by 1.616 into 10 to the power minus 16 seconds. If we solve it further, we'll get around 1000 by this into 16. Solve it and tell me what it is.
618.
0.618. So 6.18 times 10 to the power 15. This much seconds is required to transfer 1 coulomb of charge. Now, in order to see that how many days it is, like in number, days, months, years, so we can also see that because options are there in that sense only. So we again need to convert them. So when we convert them, first we divide them by 60. So if we divide them by 60, it will become minutes now. If we further
Yeah.
divide them by 60, it would become hour now.
Oh, okay.
If we further divide them by 24, it will become days. Now, if we further divide, they will become years.
360. Yeah.
These much years is this. Calculate it and see what we get. It would come around 20 years. Like that much time it would take. If every second this much number of electrons are also being transferring, it would take 20 years for that one electron
Oh,
to get transferred.
I was on mute. accidentally. Sorry. Yeah, I got almost 20 years.
Uh, did you get this question?
Yeah.
It is kind of more numeric thing. Now let us see some theory. Properties of charge. Charge is basically additive in nature. Like
Mm,
if we have to calculate the total charge, like suppose this metal space contain 10 electrons, 5 protons, 16 electrons, 81 protons. So we have to calculate the total charge. What we can do? We can simply add the number of protons and number of electrons. The number of electrons is supposed to be
yeah.
26 and number
Uh-huh.
of protons is supposed to be 86.
Mm,
So electrons is 86, protons are 86, electrons are 26.
mm,
The total charge is supposed to be 60 protons. The net charge is supposed to be of 60 protons. So like this is something we call additivity.
mm,
The charge can simply be, you can simply get the total charge by subtracting positive and negative charge present in the system. That's it.
mm,
Next, again, charge is conserved. Just like mass, just like energy, also charge is conserved. So these three things are the fundamental things of this universe for which only conservation principles are valid. Otherwise, there is no any other quantity as of now in physics where which you can say that it is conserved. It cannot be
mm,
created nor be destroyed. Because these three things are interconvertible things, you can say. We can convert charge into masses, we can convert mass from energy, we can convert charge from energy. So like these three things are interconvertible, so we can do anything like that. So that's why only conserved principle of conservation are valid for these three things.
mm,
So this is actually important that charge is quantized. So if you have to calculate the total charge of any system, any body, just do one thing, multiply the number of electrons present in the system with the charge of electron.
mm,
So if you are able to multiply the number of electrons with the charge of electron, like with its charge, we'll get the total charge of the body. That is principle of quantization or charge is quantized. If you want to explain it in terms of numbers, in terms of statements, so we'll simply say that quantization of charge is something that total charge of the system is integral multiple of charge of electron. This is what it is said. Integral multiple of charge of electron. All right. Try this out. I guess we have done enough.
mm. The last one.
Which are the given charge are not possible.
Mm, the pi of the last option, E.
Wait, let's check. So to be precise, there are a lot more options which are not possible here. The
Mm,
smallest quantity of charge is basically electron. And electron charge itself of this
yeah.
order. So
Mm,
how a charge can be of less than this order? So this is
oh,
not possible. So
mm,
ultimately this is correct. Now it is 2 times 10 to the power minus 19. But the charge of electron is 1.6 only. So this
yeah.
option is also not possible.
Okay. And then same with the 4.8.
Yeah,
That cannot
it is
exist.
possible. It is possible. It is also possible
Why is it possible?
because it is more than this number, na? It is also more than this number.
Uh-huh.
It should increase in terms of negative,
Oh,
if we're
yeah.
talking to
Oh, okay.
increase.
Mm-hmm.
Next question. All right. You can try that question in home, like as a homework. Whenever you feel like you should try this out. Next is charge is conserved. So total mass of charge which is transferred remains constant. It cannot change. All right. Try this out. Total charge in the universe is constant. What do you think? Total
Mm,
positive charge of universe is constant. Why only positive? Total negative charge of the universe is constant. Why only negative? Total number of charged particles in the universe is constant. What do you think? What is the correct statement?
mm, D.
Charge is supposed to be the quantity which is intrinsic property of matter, right?
Mm-hmm.
So it is supposed to be there in every matter. That is what this property means. So like every mass will possess it. So not only limited to electrons or protons, it is there in entire universe. So ultimately we just say that the mass is constant. Through that statement only, charge is constant came. So charge is an intrinsic property of matter, and every matter has mass. So correct option should be A, that total charge is constant. Number of charged particles do create and change. Like
Mm-hmm.
electrons or protons become some other particle. So that is something which is created. So number is not something which is constant, but total charge of the universe is something which is constant.
Mm-hmm.
Did you get that point?
Yeah.
Now we have to understand what is the basic difference between conductors and insulators. Now, first of all, you tell me what do you understand by conductors and what do you understand by insulators? Because you have seen these terms like various times reaching till 12th grade.
Um, like I've seen it like used with like um certain metals or like conductors of heat or like better conductors than other metals.
All right. So basically, you are trying to explain that conductors can be differentiated on the basis of metals, like
Yeah.
metals are conductors and non-metals are insulators. But
Yeah.
that is something which is not the definition, or you can say the comparison factor, because that is a one point. There
Mm-hmm.
should be something very fundamental which differentiate conductors and insulators on microscopic level even.
Mm-hmm.
So we found that suppose this is the matter, any object around us. So this matter has one thing which is common in comparison to every type of matter. Again, I'm not talking about metal. I'm talking about every type of matter. That this matter has a capability to possess free electrons on their surface. So we found that those surfaces which possess more number of Free electrons are good conductors, which possess lesser number are mostly insulators. So this is the microscopic level to understand the difference between conductors and insulators. Like here, we're not going to differentiate between conductors and insulators in exam in our
Mm,
answer sheet. But if you know what actually they are, we are able to answer some FRQs. Like you'll be seeing some FRQs in your exam when we'll be in the final state of your semester. So this is the entire paper which contains FRQs. FRQs, do you know what are FRQs?
yeah, free response questions.
So these FRQs, when they're asked in physics, they are asked in such a way that they'll give you numerical as well as a question in which you are supposed to explain a concept, a complete
Mm-hmm.
concept.
Mm-hmm.
So in order to explain those concepts, this is something which is needed. They're not going to ask you what is the difference between conductors and insulators when you are not writing on it. So that is something which is good. Now, which body can store more charge? Again, research it and let me know. Homework.
Okay.
Now, that is the second part of the topic. That is methods of charging. That how many ways are there through which we can actually charge a body. So suppose we have a sphere. There are multiple ways of making that neutral sphere a charged sphere, which either has positive charge or negative charge. So what are these ways? Let us understand them. First is by friction we can do that. Like whenever we are talking about that something is in contact with some other thing, so there must be a possibility that some part of charge is being transferred from something to something. And when a thing is in being contact with some other thing. So that is
Mm-hmm.
one way of charging an object. So somehow this will become charged. Surface will become charged if it is keep rolling over it.
Mm-hmm.
Another way of charging a surface or an object we have by induction. As I told you in the beginning of the class that this is the property which makes metals something very important or precious.
Mm-hmm.
Like we are always looking for aluminium, copper, gold. We are always looking for their mines, like somewhat we
Mm-hmm.
get it, somewhat we found in their plant. So why we are looking for those metals only? Why not others? Because they has a very important property called induction. They can induce charge on their surface. Like this is a metal sphere. So we can this metal sphere a positive sphere, a negative sphere, and on the same time a neutral sphere. So this charge is keep on transferring, and this transfer of charge makes the makes this property of being represented a charged body be changed. This is something we call induction. So they can induce a charge on themselves when they read it, and then also induce negative charge on themselves, and they also make themselves neutral by completely transferring entire charge of their surface to the other objects.
Mm-hmm.
That is something we call induction. Last, by rubbing. Friction is something which is we did unintentionally.
Yeah.
Like we don't have an intention, but somewhat condition is made that there is some charge transfer. Like in that very first, we can say the second page of this thing raised this question that why the tankers have chain hanging from them. Because whenever this truck is moving in the forward direction, there is lot of air molecules and water vapors present in the air. And these particles are nothing but source of negative charge. So these
Mm-hmm.
negative charge something which is keep on accumulating on the surface of this truck, which made it a little bit negative in nature because it
Mm-hmm.
is somewhat attracting more electrons on its surface. So there is
Mm-hmm.
always a chain hanging from the truck, which job is to transfer that charge from this truck to the earth so that no such disastrous condition happens. So that is the reason why this is called the method of charging.
Mm-hmm.
Is it clear?
Yeah.
Like, I just wanted to ask you that do you actually feel these things like this particular concept, like whatever I am explaining, like, yes, this is something which I have felt. I'm
Yeah.
asking this
Yeah.
because if you are able to feel this, then it is become very easier to learn and
Mm-hmm.
understand. So rubbing is intentional and it is unintentional.
Mm-hmm.
This thing generally happens in some sort of machines in which lots of companies, or you can say lots of industries, waste their lots of money on removing that excess charge. So friction is not always something which is good. It is also sometimes bad for us, like for industries, not for us.
Mm-hmm.
Then conduction. So metals has this property called induction, as I said. So they can willfully become positive and negative. What we have to do is we just need to get them in contact with some sort of charged object which can actually transfer charge from itself to the object which is being touched with.
Mm-hmm.
So suppose this connecting or charged rod we had, it is positively charged, and we just brought it in the contact with this sphere, which was initially like this, no charge. So what would
Mm-hmm.
happen is this positive charge somewhat can have this ability that it get transferred into it, and until what it get transferred, till the moment it becomes equal in both the objects. It is keep on transferring itself. Now suppose we bring this object in contact with this sphere now. What would happen is this half charge will again transfer into this object till the moment it becomes half of it. So this will vanish and half of it will transfer to the other object, B you can say.
Mm-hmm.
So this is something we call conduction. Again, I'm just explaining you the application part. There is no need of definition thing that you get that definition and learn it because you have to solve problems.
Yeah.
Find charge on both body after they are touched. So I guess you can do it. If you move this Q charge body in contact with this body, so this Q charge will equally transfer and become half.
Mm-hmm.
So final charge will become Q by 2, both for body A and body B. This is what final charge is.
Mm-hmm.
Next, who find charge on both the body after they are touched. Now it says the different radius. Now charge is something which is transferred not depending upon the radius. So still it get transferred Q by 2, Q by 2. Equal charge of this. Understood?
Yeah.
Next is induction. So we have to understand that what is induction to be precise. And induction is something that sometimes without physical contact, we can also induce charge in it. Without without touching a charged body, with uncharged body, we can literally make a neutral body charged one. If I make you explain this in Hindi, I would say that even without touching something, we can make a body positively or negatively charged. Let's see how. Suppose this is a rod which is positively charged. This is
Mm-hmm.
a neutral body A. I just brought this body close to this positively charged body. What would
Mm-hmm.
happen is this positively charged body, which is supposed to be neutral, and it is neutral. So, what do you mean by neutral exactly? What do you understand by this term? Can you
Like
please
it just
explain it?
doesn't have a charge.
Like what?
Like it doesn't have a charge if it's neutral.
This is what you think. It's not like that. It's not like that. It doesn't has charge. But the thing is, it has equal positive charge to negative charge. Like we can say that it would have equal number of electrons and equal number of protons.
Mm.
Number of electrons must be equals to number of protons. This is what it means. This is what neutral means.
Yeah, I
So
didn't know. I was just saying what my teacher told me. So, yeah.
no, it's not like that.
Okay.
So neutral means it must carry some positive and negative charge. So when this positive charge rod is being close to this sphere A,
Mm-hmm.
so the charge which is there on the rod that is positive will separate itself and reach to the other half of the sphere. Whereas the
Mm-hmm.
negative charge, which loves positive charge, will come close to the metal sphere.
Mm-hmm.
So, like, this is something by which we actually induced charge on the surface of a neutral body. So this charge, if we put that rod away, this charge will again vanishes. We won't be able to see it. But if this rod is present, this charge appears on the surface. Now, if we want to make this body a positive body, or we want to make this sphere a negative one, what we need to do it? We introduce the concept of earthing here. If we want to make it positively charged, we would earth it from the negative side.
Mm-hmm.
So that entire negative charge will went into the earth. So ultimately it will become a positively charged body. And
Mm-hmm.
if we want to make it negatively charged, we'll earth it from the negative charge, positive side. So entire positive charge will went into the earth
Mm-hmm.
and makes it negatively charged body. So induction is a process by which we can make a neutral body a charged one by simply using a concept of earthing and bringing a positively or negatively charged rod close to it.
Mm-hmm.
So this is another way of making a body charged. That is method of charging. Now this is the example which is being used here to represent the situation. So you can see it, evaluate it, and if any doubt, you can ask me.
Mm-hmm.
Again, the same thing, identification of charge, that how can we identify that there is charge in the electroscope.
Mm-hmm.
So in order to see this, first of all, we have to understand that what is electroscope, like where we are actually using it, this concept. So electroscope is something which can show us whether the body is positively charged or negatively charged. Like it is a device which checks it.
Mm-hmm.
So if a positively charged body is close to it, so it has a metal strip sort of thing, which is of positive nature. Like it has positive charge in it, which is whichever this metal strip is there. When you brought any object which is positively charged in nature, so what happens is this positively charged comes to it, and whatever charge is there which is positive, it is supposed to diverge. So divergence basically increases in this case between the strips, and they were supposed to be more far from each other. Whereas in this case, when a negatively charged body is brought, they are more supposed to be close
Mm-hmm.
because of the negative charge. It neutralizes this positive charge and they become close to each other. While
Mm-hmm.
in positive charge case, they separates, which makes it easy to clarify that object is positively charged or negatively charged. So a very basic and a very useful instrument, you can say. So this is the last topic of this class, that is Coulomb's law. So Coulomb's law is basically given by a very interesting and famous scientist
Mm-hmm.
on whose name law is being given. He found somehow that if there are two charged bodies, so they have capabilities of pushing them away or pulling them closer,
Mm-hmm.
depending upon the nature of the charge is present on the objects.
Yeah.
So he did lots of study, he did lots of experiments, and he found that positive charge and positive charge repel each other.
Mm-hmm.
Negative charge also repel each other, but
Mm-hmm.
positive and negative attracts.
Mm-hmm.
So this is something which I've already everyone has seen, but he found the magnitude of that force, like by how much force it will pull or it will push.
Mm-hmm.
So he found and said that force is called electrostatic force, and it is given by product of charges between which the force is being calculated
Mm-hmm.
and and the distance of separation between them, like how much distance they are apart.
Mm-hmm.
So when we put that equation, we found that electrostatic force is nothing but k times product of charges divided by the square of separation between them. And
Mm-hmm.
that is something called Coulomb's law. So again, this is a law. So these are the findings based upon the experiment of Mr. Coulomb. And whatever the findings of this law is being accepted everywhere as it is valid till now. No one has able to prove it wrong.
Mm-hmm.
So the key concepts are these electrostatic forces acting on the two different objects are equal in magnitude. So if there are two bodies and there is electrostatic force exists between them, the force applied by the object A must be equals to the force applied by object B. So these are called action-reaction pairs. That is third law of Newton. So third
Mm-hmm.
law of Newton is also valid everywhere. That's why worlds accept it. Second, defined for a point charge only. So somehow if this charge Q has some mass or the shape or size, we cannot use this law. It is based for point charges only, like this, which is supposed to have some charge but no mass. Next, it acts along the line joining the two charges. So whatever line on which they are, the forces act on that line only. Whatever line on which they are, the
Mm-hmm.
forces are supposed to be act on that line only.
Mm-hmm.
Center of mass and force is conservative in nature. Based upon center of mass and the force is conservative in nature. This conservative thing is something which we have studied in grade 11. So if you want to know more about it, we can discuss in the later classes. Force between any pair of charges is independent of third charge present. Like whatever force is acting between the two charges, like one or two, or there is another charge three. So whatever force acts between them is not influenced by this one. Although there might be a separate force acting between them also, but this force is independent of its presence. It follows inverse square law like this. This is something we call inverse square law. If there is something like a quantity which depends upon some other quantity, like inversely and in square terms, that something is called inverse square law. Next
Mm-hmm.
is it is a long range force. The long range force means it can act like almost everywhere, like till
Mm-hmm.
infinity. Coulomb's law holds over large range from atomic distances 10 to the power minus 15 to many kilometers. Like if there is a very big charged particle around one country's border, like a very big, like across the border, that much big. So it do has capability to pull all the elements present on there on one's countryside. Like this is a hypothetical situation, but it is something which is possible because of this law only.
Mm-hmm.
So the question is, if k q1 q2 by r square, find force in following cases. Q1 is doubled. So if Q1 is doubled, force will also double. If Q1 and Q2 both are doubled, then force will be 4 times. If R is doubled, force will be 1/4 of its actual value. If R becomes root 2 times, force will be half. So these are the answers. I want you to figure it out more. Just look at the problem.
Mm-hmm.
Another question. So the question says two charges 10 PC. So PC means picocoulomb. It is one of the smallest unit. So 10 PC means 10 to the power minus 12 coulombs. That much small it is. Again 5
Mm-hmm.
PC means 5 into 10 to the power minus 12 coulombs. Picometers. Are placed 20
Mm-hmm.
centimeters apart. Like this, 20 centimeters apart. 10 PC, 5 PC. The ratio of Coulomb's force experienced by them is. So we just have seen that whatever force is applied by this charge and whatever force is applied by this charge, this is always equal. So ratio would always be 1:1.
Mm.
Understand?
Yeah.
Discussion on K and permittivity. So in the relation, we have seen that there is something K Q1 Q2 by R square.
Mm-hmm.
So that Q1 Q2 by R square is fine. We know Q1 is magnitude of one charge, Q2 is magnitude of other charge, and R is something which is the distance between the charges. But what about this K? What is this K? So this is something called proportionality constant.
Mm-hmm.
And this constant has a fixed value called 9 into 10 to the power 9. And this value is found out through so many experiments done by Mr. Coulomb. And this is something which depends upon the medium. Like this Coulomb's force or electrostatic force is medium dependent. So like if medium change, it becomes water, it becomes some sort of mixture, it becomes some sort of air, some sort of gas. Then there is something present in this 9 into 10 to the power 9 which might get changed. And that is something we call permittivity. So this permittivity is actually the measure of medium, you can say. Basically, a number which defines the medium.
Mm-hmm.
So these are constant values. These are supposed to be there in the question always, but we should know that what these values are and what they actually means. So these are some permittivity constants, like for some medium. Like for vacuum, its value is 1. For air, it is 1.0054. For water, it is 80. And for metals, it is infinite.
Mm-hmm.
Infinite means which cannot be measured. So this is about the today's class. And I suppose that after doing the revision